In this video, I'm going to introduce you to a new theorem. When you're trying to find out the limit of, let's say, the nth root of a function. So here you're trying to find out the limit of this thing here, the nth root of a function. That's like you doing this, finding out the limit of, let's say, the seventh root of I don't know, a function in here, something like this. So what it's saying is that, well, when you're trying to find out the limit of the nth root of a function, you can actually break into the square root, well, break into the root. So rather than finding out this, you can concentrate on finding out the limit of f of x here, and whatever that limit is, and then just nth root that limit. That's what it's saying. So earlier when we had something like this, find out the limit of the let's say the seventh root of something like this. Okay, just break into this. So it's like this. Hang on. The limit of 2x2. So what this is saying, is concentrate on finding out the limit of this. And once you've got that limit, let's say capital L here, just nth root that capital L. Okay, hang on. Let me start again. So here, let the limit of this function here be capital L. So what we're saying is that, let's say we know that the limit of this is capital L. Let's just say it's capital L. Okay, and n has to be a positive integer. So we are trying to find out, let's say the 88th root of a function. Of well, what it's saying is that this number here has to be a positive. So here in this case, you can do a square root, or you can do the cube root, or you can do to the power of 4. But just don't allow this to be a negative. Okay, that's what it's saying. Let n be a positive integer. Okay, well, if n is a positive integer, so well, what this is saying is, when you try and find out the limit of this here, you can actually concentrate, well, break into the square root and just find out the limit of this. And we're saying that the limit of this here is capital L. Let's just say the limit of this is capital L. Well, whatever capital L is, then you can just find the nth root of that capital L here, and that will be you finding out the limit of this. So basically, you finding out the limit of this is like you breaking into the roots here, and just concentrate on finding out the limit of this. And then whatever the answer is, then you can just take the nth root of that capital L. Okay, and this bit here, provided that L is bigger or equal to 0 when n is even. So what this is saying is that, suppose you have a square root of something. Here, what this is saying is that the limit here cannot be, let's say, -4. So here's you trying to find out the square root of a negative number. So what this is saying is, provided provided this here is a positive limit when this is an even. So for example, let's say to the power of 4. This is an even, you see, provided when n is even. So when this is even here, you cannot have a negative limit. If yeah, you cannot have a negative limit. So that's just like you saying, okay, let's say it's 2 for, let's say square root. When it's a square root, you cannot have a square root of a negative number. So it's saying n has to be greater than n has to be greater or equal to 0 when this number here is an even number. You see, when it's a cube root, then you can have whatever you want. You can have a negative 7, because you can actually find a cube root of you are allowed to have a negative number here when this is odd. But when it's even, like a square root, when it's a square root, we don't bother writing a 2 here. You cannot have a negative 7 here, because you finding out a square root of a negative number, well, here what it's saying is that when n is even, just make sure the limit is greater or equal to 0. Okay, but when it's odd, you can have whatever you want. That's what it's saying. Okay, in the next video I will give you an example.